we are seeing similar design patterns. The design patterns which look similar but they are different. And in that series, we have a decorator design and we have visitor design. So both are different, both why they are similar. Decorator design pattern means there are two things generally. Now in Python era, everything is attribute. Like if we have a user-defined function also in the class, then that is also an attribute. So the only difference between integer as an attribute of a class or class object and any user-defined function is one has called underscore that is a special attribute it has, so it is callable. Otherwise, all are attributes. So that is the concept now it is coming. But anyway, in the class, we have kind of two kind of things in a class. So we have attributes and we have methods. So like in C++ kind of a static, in Python kind of program, uh, we can have attributes added at runtime. So we can add attributes at runtime. So that is the concept in Python. So many design patterns are kind of implicit in Python. So design pattern they generally they enjoy on polymorphism. So that is something that it provides. So Python is inbuilt polymorph. Everything is object pointed, and anyone can override any. So that is the case. But anyway, traditionally, if we talk about design patterns like visitor design pattern and decorator design pattern, then decorator design pattern adds attributes. If we need addition of attribute in a kind of like if I have a there are few classes that we cannot like built-in classes we cannot enhance it. We have to derive from it, and then we can enhance it. We can means we can extend it. So still means there are classes that we cannot make it kind of amendment. So in those cases, if we need to add attributes, then we use a decorated design pattern. And if we need to add behavior, okay, one means behavior in the sense that methods. So method generally it comes in behavioral design pattern because it is more versatile. So visitor comes under behavioral design pattern because we are adding methods or behaviors at runtime. And decorated design pattern comes under structural design pattern because we are adding attributes at runtime. So these attributes concept forms in a structure of a class. So this comes under a structural design. So a decorated design. So how we can add attributes to a class without kind of changing a class. So if I have a class, decorated design pattern is heavily used in Python also, where we can we can declare a decorator in front of function or class, and then it becomes the function. If I have a decorator, it starts with ampersand. So if I have a decorator before a function, then function becomes decorative, and anyway we have the decorator. So how kind of a decorator concept comes into the picture? Like I have a printer, and if I say I have a printer, I don't know which printer. Means it has a function called print, and I pass a page. Okay, so printer. Then in my call means I have algorithms written, and at the end, so like I have a printer pointer. Printer pointer I received through a function parameter. So in the printer pointer, I just say print. I pass the page and it prints the data, whatever the data kind of I can say print page and the data, and it prints it. Printer can be any type. I don't bother because it gives the it implements one with interface, and it gives a method called print. So I don't care. So it prints. Now, with the same printer, I want border also. So when it is printing something along the border, either it can be a thick line or my company name whatsoever. Now in the algorithm it's not available. So printer algorithm takes the page, takes the data and it prints in middle, in the center. Now if I want border, it's not possible. Means it's become a chaos condition, chaotic condition. That I receive a printer pointer and if I say print, then it would not print the border. What I can do? So this is decorator design. So idea is that the printer realizes an interface. So interface name is I. So from I, printer realizes. If it is not realizing interface, we'll make it. So in the design, we have an interface. From the interface, the printer class realizes it. From the interface, we have decorators. So both are, from the interface we have printer. From the interface we have decorators. Decorators are also classes. Now printer realizes or implements interface. Decorators they also implements interface. If they implement same interface, means with the same interface pointers, we can call functions. If there is a print function in the interface, then against all the subclasses, we can call print. Okay, so this is decorated design. So I have an interface. From the interface, I have the concrete class that derives from the interface, implements the interface, realizes the interface, and it has a method, any method like do it or print. From the same interface, I derive decorator classes and provide same methods like print or do it. What's it? Now, when I pass the function which is doing all the job at the end, it says printer print, so it receives a printer pointer. So now with the design, it would receive interface pointer. So from the interface pointer, or it was anyway, if it was receiving something abstract, it is fine. Now with the new design, now it will receive interface pointer and it is permanent. Now through the interface pointer, I can say I print. Now interface pointer, if I pass printer, a concrete class itself, then it will print the way it was printing. So this is a function, algorithm function. From the function, there is a parameter. That parameter is interface pointer. Inside the algorithm, we are doing manipulation on the data. At the end of the function, I am saying I print. So interface pointer, I am calling a print. If I am calling a print, then it will print the data on the page. Now, if I the interface pointer, if I pass the actual printer as a concrete object, then it would print on the through the concrete object print function. So the on the page data is printed. Now how we structure? That's why the structural design part. So I have a class which is kind of I can say as a border print. Border printer is a new class that derives from interface. Printer already has a class that derived from the interface. Now border printer contains printer. Okay. So border printer and printer they both derive from same interface I. Border printer when I instantiate in the constructor itself I can pass the printer object. Okay. Anyway, it takes I pointer only. So border printer in the constructor it takes I pointer, and in the object I pass the printer. I mean border printer contains the printer. Now, when I have algorithm function in the interface pointer, I pass the border printer object. Since our algorithm will never change, at the end it calls I print, but I is border print. Now border printer takes the page and very nicely it prints the border. Once it is done, that page is passed nicely because it has the printer object inside, contains it. So then it passes, or we can say composes it. It passes it to the printer, and Mr. Printer does its job. At the end, whatever the output what we receive is a page where data is printed and along a border is printed. Now I want one kind of logo on top right. I have a logo printer. Now logo printer derives from interface, and I have a kind of border printer derives from interface, and I have printer derives from interface. So this is a core architecture. We can have kind of hierarchical architecture also. So from interface, our printer is derived. From interface, we'll have decorator derived. From decorator, we can have border printer and logo printer like that. Or from border printer itself, I can derive logo printer if you feel that it's a part of a border. So this kind of hierarchy there, at the end it is I pointer, interface pointer. So this way, so when whatever the object, the concrete class, whatever concrete class is doing, if you want enhance functionality, so whatever, suppose like in Python, if I have a function called func, but I want a kind of more functionality than func provides, then we have a layer of decorators on top of it. So first decorator would call contains second decorator. Second decorator contains third decorator. Third decorator contains the function. Now the Python interpreter returns the topmost decorator as the return. So our function is way inside it. So whenever in our code I call my function, actually decorator gets called. Now decorator they do their job, then call second decorator, they do their job, then call third decorator. They do their job, they finally they call the actual function, but it is not in our hand. And then the result is returned. So decorator is used when we want more functionality, more attributes with the same interface what we were using earlier. So if I have a function already written, and if I want enhanced functionality inside the function, no need to write function again. We can have a kind of decorators. Decorators comes into the picture up front, and they keep containing the other decorative at the end function comes into the picture. So whatever returned from all the game is the topmost decorator. Like that, in C++ and those areas also, the topmost decorator they contain the other decorators. At the end, we have the object. So we consider in this fashion, like if I have a logo printer and then border printer and then printer, means printer, our old printer has now new attributes called border drawing and logo drawing this way. So if I want to make a printer grow in its attributes without changing the algorithm where we are calling the printer, and then without changing the printer class itself, then we can go with the decorators. And the schematic diagram, class diagram, inheritance diagram of decorator would be that the actual concrete class would derive from an interface, then from the interface, all the decorators would derive, and then obviously they will implement those abstract functions, virtual functions, and through those functions, slowly we'll reach the actual concrete class. So this is decorated design. Amazing. Okay. So this comes under a structural design pattern. Can we think in real life how it can be decorator design pattern, where the decorators, the new decorators and the concrete class that is the decorative and decorators all follow same interface, and we start with the decorators and the wrapper is getting unwrapped one by one, and then we feel that then finally we come to decorating. So okay, so in war kind of situation, so there was a warrior, Changez Khan, okay, a Mongolian warrior, Changez Khan. I believe the only warrior who never lost any war, Genghis Khan. So, what was the kind of the speciality? I mean, I'll give example of the Genghis Khan in visitor design pattern also. So, in the decorated design pattern, so what is the main kind of the the principle? What was the main charm of the army of the Genghis Khan? Genghis Khan himself was a big warrior, but the structure of the army, what he used to make, that was exemplary. At the runtime, when war is going on, if something harm is happening in the army, then that would be replaced immediately. This gives the concept of interface, one thing. Second thing is, you can add a cavalry. Like in the war, you feel that you should add camel revenue. I mean, cavalry. Okay, so you have a horse cavalry. Anyway, you have elephant marching, you have soldiers marching, and then you have a soldier with kind of horse cavalry. Now, at runtime, when war is going on, and then suddenly you feel that on this kind of land, camel cavalry would be very fit, but we cannot add, right? Because camel cavalry, they have their own rule and regulation. Suddenly they cannot come and they start fighting the way you are. They don't know. They don't know. If they follow same interface, the way horse cavalry or marching elephant or marching warriors or the warriors who are with bow and arrow, if they follow same interfaces, you can fit in at runtime. This is a structural design pattern. Means since camel cavalry also follow the same design, same kind of interface with the same method, they can fit in at runtime. Now your army structure is growing. Your attribute of the army has attribute, or the warriors has attribute as marching warriors, marching elephants, horse cavalry. Now one more attribute came as camel cavalry. So nice. It was there. This is how Changez Khan was invincible. No one could defeat Changez because of the design patterns he used and the way things he would replace, bring it new, take it away, and nothing would have changed. Means all the soldiers they would feel the same because everything went through interfaces. And then he always won. So that is a decorator design pattern. Now we'll see visitor design pattern. A visitor design pattern. So we talked about a structural design pattern, that is a decorated design pattern. So in decorated design pattern, we add attributes. So it's a kind of whatever the class we have, and inside the class, if I want to add attributes, then we place wrapper classes on top of it. Being they derive from the same interface, so wrapper class function what we want from the concrete class, we call the same function through the same interface. This is what we saw. And the wrapper they add their functionality and they call the next level, next level, next level till you till it reaches the actual the kind of actual decorative, that is the end one, and then it does the job. So this is decorated design pattern. So this comes under a structure because we change the complete structure following an interface, and the code which is written using the interface to call a certain operation on the decorative, it is blocked by decorator class instance following the same interface, and then they get called and they have the other classes as containment. So this is decorator, And suppose there is only one decorator. This is decorator and this is concrete class. User calls the decorator's function considering that it is concrete class. It does its work and then finally call the concrete class. So there is extra kind of attribute that we get like a printing border along the page. So before it print the data on the page. Now visitor design pattern. So visitor design pattern comes as if we want a behavior at runtime. Okay. So there is a class and it has set of behaviors like kind of uh, like it has so many things and it wants a behavior like it kind of it has uh, I believe we are taking example of printing. So it has methods to print. So print on inkjet printer and print on kind of dot matrix printer. And now it wants an operation to print on kind of a laser print. So inkjet printer and dot matrix printer. It has a function. Now it wants to print on a laser print. So that is the new kind of operation it wants. Or if we take the previous example, then if it is has a printing option, then it wants a new thing that is printing the border. I mean, let's continue with the same thing. So in the decorator design pattern, we had a printer and it used to print the data at the center of the middle area of the page. If you want the border, then we added the attribute in a terms of a new class and that becomes a wrapper over the previous class and they follow the same interface. Now in visitor design pattern, if I want a new operation, there I call it new attribute. I call it here as new operation. So new operation being like printing a border on a particular. So I have a printer, but printing border is missing. So whatever the operation we want, so for that operation, we can have a separate class. It's like same thing. Now now we have printer class and we have a separate. Now we want 15 separate operations. For 15 separate operations, we need 15 classes. The way it is in decorator. But decorator and the concrete type they derive from the same interface. Here, whatever the operation we want, all they derive from a kind of separate class called visitor. Now, what I have a printer class that is already I have, and I want border printing. So, border printing would inherit a separate class called visitor. So, visitor is interface. Okay. Now, in the printout, suppose first I want a border to be printed. I say there is a function, whatever we have written the printer, so we'll introduce a function called accept. Accept is a virtual function. So I have a ready-made printer which prints nicely. And there, as per design, we place a function called accept. That's it. Except a visitor pointer. Already have a printer. Now I want 15 new functionality in the printer, operation on the printer. I have 15 different classes. All they derive from visitor class. And now this printer has a function called accept. Accept takes visitor point. Now if I want border to be printed, then border visitor that derives from the visitor. I say accept border. Okay. Now in the accept code of maybe it will come in the interface of the printer. It calls the visit. So I call accept against the printer. Accept calls the visit against the a visitor, and visitor would get the visit function called. getting the this pointer, because if you call the function in interface programming, you receive the this pointer. So, or self in the Python. So you receive the this pointer as whoever called you. So whatever printer we have, inside the printer I have function accept. Except the visitor pointer. Against the visitor pointer, which is polymorphic, we call a function called visit and pass self. Now visit get called in the visitor, and who called it, that pointer I received. Okay, so I have a printer, it wants a new operation to be done. So there is a function called accept, which takes the visitor pointer, that is polymorphic. Against the visitor pointer, it calls function called visit, passing self. Now inside the visit of the uh, of the visitor, it receives the object through the interface. Which object needs to be visited? Done. So now visitor. So if I want border to be printed, I get the pointer of the printer. So printer had everything, paper and what needs to be. So it knows the printer. Since it is written specifically, this new operation is written specifically. If suppose if I have two printers, one is laser printer, inkjet printer. If they pass self, then it has two visits. One visit is for laser, one visit is for uh, inkjet. But it doesn't care. It calls visit passing its pointer. Now it gets that visit called, and then it knows that it is laser or it is inkjet. Then, based upon that, first it places the border, because this is the border operation, and it is called dual dispatch also. We are doing dual dispatch in the sense we are calling visitors visit, and visitor visit is receiving the concrete class on which it has to visit. Then it calls those functions against the class, and first it does it work, and then it does call the print that anyway it prints. So this is visitor design pattern. So uh, we saw like decorator design pattern where we add attribute. Here in visitor design pattern, we add operation. So operations are added. Each operation is given a class structure, and those class have functions called visit, and against the visit, who the concrete class for which operation need to be added, it passed through. So the visitor operation, that is in terms of class, they receive pointer of the object that they need to serve, and after that they can do their work, add their operation, and then call this point. So this is a typical a decorator and visitor design pattern. I mean, if you want to know more, then you can visit our website, and there we have two disclosures. One is C++ and one is Perl. On the on the uh, on the this design patterns, there visitor and decorator can, because visitor is little bit a little complex because it is dual dispatching. So I have a concrete class, I have a visitor class. Concrete class we call accept, passing the visitor class, the visitor which needs which operation I want to add against the visitor. It call the visit, passing its own pointer. So visit gets the pointer, and if visitor has is serving so many classes, so for so many visit, like if it is a kind of adding border and adding border to five different printers, then five different visit it writes, because functions can be overloaded, and the particular visit based upon the pointer type, based upon the pointer type it would receive, and then since we are receiving the concrete class, so this guy call this and passing its own pointer, and then again this pointer it starts calling the function. First it serves what it is supposed to, and then it kind of does it work. So calls first it serve and then calls. So this is dual dispatching in the visitor design. Okay, so a scenario comes as what is the real life scenario. So we are giving example of Genghis Khan army. So Genghis Khan army is supposed to be kind of many Nadir Shah means we're talking about Asia, but anyway there are other warriors also like Alexander Al-Sikand. So he was also kind of uh, invincible, we can say. So Genghis Khan army style. So one we talked about uh, in the structural design pattern where cavalry can be added. Like if camel cavalry is missing, then it can be added, and it can be added in a way that there would not be any headache. So it could just fit in because it is following the interface. Now, since we are talking about adding operation, then like five horses are falling. Means during the war, five horses are falling on the ground, and five horses need to be replaced. So that is the scenario. Now the horse filling, that is a separate class. So against that, so we can say that please visit. So we can through accept we call horse filling department and passing the horse cavalry as a pointer. Now the horse filling department receives the request as as horse filling because horse cavalry we are passing it. So there are two things. There are camel cavalry, horse cavalry, elephant marching, and then soldiers marching. There are so many classes. So horse cavalry class would call visit through accept and then finally visit inside the class called filling, just filling. So the filling is a visitor. Inside the filling we have visit, and then filling for horse visit, filling for camel visit, filling for marching, elephant marching. Like these are the visit means override function. When I pass horse cavalry, then immediately that function get enabled. Visit horse cavalry. Now, it not only knows how to fill it, it gets the pointer also where to fill it. Interface based programming. Now, it fills five horses at runtime because it knows where to fill it because full horse cavalry data structure it is receiving. Whose camel cavalry data structure it is receiving, filling department. Okay, there can be other department where everyone is alive, but the person sitting on the horse he loses the archery somehow. So archery department it would go. Class is a new class there we need a new kind of archery to be filled in. It receives horse cavalry as a pointer. Then it can do its operation, and then it knows the status of horse cavalry, how many has fallen, and what is the current status of the war. Means Genghis Khan was amazing. Okay, probably in the like the new era of the history where it starts from Gautam Buddha, like king like Ashoka. So from there, the new era in the history starts. So probably Genghis Khan means if I do the kind of the numbering, who win how many wars, then he was parallel to King Ashoka. So the way he fought the war means bringing in over the kind of in the war surprisingly bringing in camel cavalry automatically, or if any horse is falling, then five horses he would replace quickly, and his army would be same when it going at the sunrise and it is coming at the sunset. No change in the army. How someone can win? Not possible. Means people expect that as the day climbs, then a army would decimate slowly, and there is chance for the other team to dominate. But if it is everything is exactly same at the noon time and in the post noon, then you cannot win. So how you fit in the other cavalry and at run time you change things as per the design pattern, that was classic of Genghis. So he was invincible. So this is the way, like we have filling department, we have archery department. So many new operations are there they follow same visitor pointer. If anything need to be filled, like filled, then filled visitor would be called passing the horse cavalry pointer. Horse cavalry pointer, then that particular function, visit function, again the horse cavalry pointer would get called. And then with the pointer of the horse cavalry, so he's browsing everything, that what is the situation and how, where the horses are, and those kind of things, and then it can fill through the interface quickly. Changez Khan was an architect. This is what I would say, that he was not a warrior only. He was an kind of a top class architect. So this is a decorator, a structural design pattern, and behavioral design pattern, visitor design